Regular expressions are incredible, but they can also be incredibly terrifying. To make matters worse, you've probably heard that regular expressions are expensive and should be avoided. In this video, we're going to see how easy regular expressions can be, and we're also going to see how they can be very quick and efficient as well. Now, before we get started, there are 3 things you need to know. First, if you want to improve your C# skills, you should subscribe to this channel. With over 450 C# videos and counting, this is the place to learn C#. Second, if you'd like free C# resources, go to iamtimcorey.com and click on the Resources tab. There you're going to find my podcast, a C# project page, and a lot more. Third, if you need a deep education in C#, I have dozens of courses to help you out. Not only will you be getting a world-class education, but you'll also be helping to fund my free content so that everyone can have a great education, not just those who can afford it. Okay, let's jump right into Visual Studio. We're going to create a new project that's a console application. So I'm going to choose Console App, and let's call this Regex Demo. We'll call it Regex Demo App. And if you want the source code from today's video, yes, .NET 6, and no, don't check this box. If you want the source code for this video, go in the description of this video and you will see a link to download it. You'll get an email, ask you for your email address. You'll send you an email with the code in it, okay? So let's start off from scratch with nothing in here. We're going to start from a blank slate. And actually what I'm going to do is I'm going to, at the very top here, I'm going to paste in a large code comment. And this is a cheat sheet. And I want to start you off with a cheat sheet because regular expressions have a lot of scary looking things in them. But really, if you have this cheat sheet, you're pretty much set for building your own or for diagnosing someone else's. Okay, so what we're going to do is go through and start using this cheat sheet. So I'll explain more about each of these pieces in a little bit. But let's start right away with a regular expression. Now, in order to have a regular expression, we need to have a using statement. So let's do it right here underneath our cheat sheet, using system.text.regular expressions. All right, that will allow us to use regular expressions. Now, let's talk about what a regular expression is before you start seeing them. A regular expression is think of it like a query. So if you were in SQL and you said, hey, I want to look at this table, but not every record. I want to say where the last name equals Corey, okay? That would be a query where you kind of filter down the results. Well, a regular expression is kind of like that in the fact that we say, hey, I want you to find something. But the cool thing is it's not just as simple as I want you to find the last name equals Corey. It's I want you to search this entire text file and find me every phone number in it. What's the phone number? Don't know. Could be different. And we're going to do that by the end of this video. So that kind of thing is a lot more complicated because you can't just say, hey, does this line of text equal this phone number? Well, if you don't know the phone number you're looking for, how would you know? And that's where regular expressions come in. Regular expressions are pattern matching. They say, okay, you've defined a pattern. Now let me go find the match for that pattern. So let's see us, and we're going to start by starting small and simple, and then kind of grow until we get to that more complex find every phone number in a 5,000 line text file. Okay, so let's start with something simple. We're just going to say, let's start with a pattern. And then we're going to have a to search string. Okay, so the pattern is, here's the pattern to look for. And then here's a string to search it in. All right, so let's do this. Let's create a pattern that says, hey, I'm going to look for, let's look for Tim. Okay, so we're going to look for Tim. That's a pattern. Now, that's just 3 characters, but that is technically or can be a regular expression. It's a pattern to look for. It's a very specific pattern, but it's a pattern to look for. So if I were to say Tim Corey, okay, it's going to find, in fact, let's do this. Let's wait on the the search string for a minute, and we're just going to search a number of different ones all at once because it's going to be faster. So let's do console write line, and we're going to say right in here, regex dot is match. We're looking for a match. It's going to ask for two things, an input and a pattern. So the input is this, Tim Corey, and the pattern is our pattern we're looking for. So what we're going to do is say, hey, we actually are missing a paren at the end. We're going to say in this expression, we're saying, hey, is this pattern, which is Tim, is that found in this string? Yes or no? True or false? And we're going to get back a true or false. And we're saying console write line here. So let's say, really simple. All right. So we're getting super simple here. We're just saying, hey, this console write line is going to say Tim Corey, true. We just found Tim in Tim Corey, hopefully. But let's copy this and do it a couple more times and throw it some curveballs. Timothy Corey. That's actually my name. Timothy. Now, that's cool, but what about this? You see the TIM there? Sometimes. Okay, so we're going to find out if it's in sometimes. Let's run this. What we've got is Tim Corey, true. Timothy Corey, true. Sometimes false. Okay, so it didn't find the Tim in sometimes. Well, why is that? Well, because of capital T. In fact, if I changed this, let's actually add another one here. Let's add another one like this at the bottom, and we're going to say lowercase t. If I did that, we get lowercase tim Corey false. Even though it's separated out, it should be found, right? No, because it's case sensitive. Now you can make a regular expression not case sensitive, but that's not usually ideal. So instead, one of the things we can do is we can say this. Now, if you go up here to our chart, we see that this is a range. All right, so I have now said either capital T or lowercase t. All right, and if we run this again, we'll see that all four of them are true, including sometimes. We just found Tim in the middle. So we have found matches in all four of these strings. Now, we wouldn't want to do that with every letter. I mean, technically we could, but that would be kind of a pain. So we could say right here, our options is ignore case. All right, we can do that. Like I said, it's usually not the best, but we could ignore case here. In that case, we have the Tim like this, and you find all four are true, even though this is a lowercase t, and so is this. Okay, so you can ignore case. Again, not my preferred, but you can do that. All right, next up, let's make this a little harder. So what if we said that we're looking for the name Tim, only Tim, as a name, meaning capital T, lowercase im, with spaces on both sides. So we're really looking for something like this. But that's not going to work necessarily. So let's just ask for Tim to start, and let's run this and see if any of them apply. And we know the bottom two won't. We have two, true and false right now with just Tim, right? Because these two fail because lowercase t. Okay, but what if we wanted to say that we wanted this, let's start with simple. Let's start with, it has to start with Tim. Well, come back up here, starts with. So we say, starts with Tim. And we run this, and we get true, true, false, false. Still, let's change this up a little bit and say I am Tim Corey. True, true, false, false. Because even though capital T, lowercase I am is in the list, it's not starting with Tim. Now, remember I said before, what if we're looking for the name Tim, which we could say, well, I want this to be Tim surrounded by spaces like this one is to see that it's a word. So I could do this, or I could say /s. If we look up here, whoops, wrong slash, /s, we look right here, white space. So I could say /s again at the end for white space at the end. But notice we get the red squigglies, unrecognized escape sequence. That's because for regular expressions, we have to use the string literal character, the @ symbol, in front of it. Because otherwise it says, actually, you're trying to escape an S, but I don't know what an escape S is. It's not thinking regular expressions. It's thinking of the C# escape sequences. So we want to say this is a string literal, meaning take this literally as it is. There's not anything special in here. Now, for regular expressions, these are escape characters, but they're an escape character for regular expressions, not for C#. So that's why this tells it for C#, there's no escape characters here. For regular expressions, when it processes it as a pattern, it'll say, oh, that's an escape character. So yes, it's a little bit different. Okay, so now we're saying, is there a space on both sides of Tim? If we run this again, we'll now see false for all 4 of them. Well, why is that? Well, that's because I've been modifying the wrong thing. Whoops. This is why it's not great to have duplication in place. I didn't modify that. So let's do this again because I messed this up and it might have worked. It's not going to, but it might have worked if I had said starts with. Notice it still says false. Okay, it doesn't start with it. It's in the middle there. Okay, now let's look for the space at the beginning and end. And you run this, and we get true. So I am Tim Corey is true because we've got Tim standing alone. So we've said yes, the name Tim, not Timothy, not Timmy, not any other variant of Tim, and not sometimes with Tim in the middle. We're looking for the name Tim. And we found it in the last one. But that's really not complete because we found it in the first one too, but there's not a space before Tim. In fact, if we would change this, there is a space before Tim, or run this, now that's true, but it's not right. I mean, we shouldn't be doing that. So how do you find where Tim is at the beginning? So we found Tim in the middle with spaces on both sides, but what if Tim is at the beginning? Well, we've got the option of this range right here, but we also have this alternative. Okay, so X or Y. Well, we could say, let's put this in parentheses. So S or the start. Okay, so you said the start of the string or, that's the or right there, or a space. Let's run this again. And Tim, I took the space out. Tim Corey is true. So it found it at the very beginning. So now we're finding Tim in more places. It's more accurate to what it might be in a text file, where we might find that Tim is the first word in a sentence. You know, Tim went to the mall. Well, then Tim is the beginning of that sentence. Therefore, there wouldn't be a space in front of Tim unless it wasn't the first sentence in the paragraph. So this is important to know how to start thinking through all different places that could break your pattern. So now we're looking for at the beginning or with a space in front of it. But what if Tim is the last thing in the line? So we know that this works. We know that this works, but let's say sometimes Tim. Okay. Let's say always Tim, because that way there's not Tim in the name to be confused by. Okay, so always Tim, where Tim is at the end. And if we run this, always Tim is false because there's no space after Tim. So what do we do? Well, we're going to do that grouping there where we say alternative. So or, and what's our end character? A $sign. How do we know? Right up here, ends with. So either there's a space afterwards or it ends with Tim. We run this and we see always Tim is now true. Now, I do want to point out at this point that there are other ways of doing these things. Regular expressions are like programming in general. There's more than one way to attack a problem. And I would encourage you to try out the different ways to see if there's any efficiencies in one versus the other. But just because you can do it in multiple ways doesn't mean that your way is wrong. It just means it's different. And like with programming, different doesn't mean bad. It means it's different. Okay, so with that out of the way, because you may have come across this in a different way or had a different thought on how to do this, and that's fine. Let's talk about this pattern for a minute. Do you notice how complicated it looks? It's got lots of special characters. Okay, so at the very beginning, we have 1, 2, and then 1, 2, 3, and then 1, 2, and then 1, 2, 3. We have, 10 special characters with only 4 what we call regular alpha characters. 5 alpha characters. That looks complicated. But when we started breaking it down and started looking at what it's actually doing, it wasn't complicated. It was just we had to put in all the different possibilities. So if we start with the very, very simple stuff, just Tim, and we start adding a little bit at a time, like, a space before Tim. Well, a space or the start. And at the end, a space after Tim, or a space or the end. And you start building this up, that's when you get the more complicated statements. But when you actually take time to figure out what it's doing, it's not nearly as complicated as it looks. Now, with that being said, you will see some pretty complex regular expressions. I would encourage you to start off simple and practice these things. This video is an intro to regular expressions. It's not going to be a comprehensive look at everything you can do with regular expressions and training you deeply in all of it. But I would encourage you to go back to here, look at these, and start practicing. One of the things I tell people a lot is that the only way to really understand something is to practice it. If you just watch what I do and go, yep, that looks great, I got it, and then try and do it and it doesn't work, then you get frustrated. I would encourage you to try this out and practice it a few times and start simple. Don't start with the complex, start with simple. Okay, now let's talk next about this. Okay, so we've been using what's called the static version of regular expressions. The static version of regular expressions is a static method we can call like isMatch. And this passes in the pattern. This pattern is not precompiled. So what does precompiled mean? Well, in regular expressions, C# will turn this into a pattern, a high-level pattern that it knows about, but it's not in the intermediate language that C# gets compiled down into. And so when we go to run this, it has to turn this into intermediate language first, and then it runs it. We can precompile this, which means that we compile it once, and then it's already done so that it's faster for all of these runs. That's the theory. Okay, let's talk about practice. First of all, if you're using the static version, which is what we're doing right here, where we don't have to instantiate a class, then when you put a pattern in, it's going to compile that and run it. But then when you use it again, it's going to remember, it's going to cache that compiled plan and use it over again. for up to 15 plants. So as long as you don't have 15 different patterns that you're using, or 16 different patterns that you're using, you should be fine to reuse without pre-compiling. Now, the cost of that compilation happens here the first time you use it when you're using the static version. You can pre-compile it at the very beginning of your application, and then the cost goes there instead. But I want to point out, some people look at regular expressions and say, oh my goodness, they're so inefficient, you should never use them. And I strongly disagree with that. In fact, I would like you to test it. So let's do this. Let's run this. Now, this is the pre-compiled version once you run it once. But let's run this this expression. What we're going to do is match. Going to return a true. We're going to ignore it. Okay, so we're going to copy this or comment this out, and I'm going to say for. Let's do 100,000. So I'll loop through and run this method 100,000 times. Now, is that a lot? Yes, that's a lot. Okay, so we're going to run this regular expression match 100,000 times. Now, what we're going to do is we're going to create a stopwatch. So we're going to say stopwatch, and that adds, by the way, the using for system.diagnostics. We'll call it stopwatch equals new, and we'll say at the very beginning here, stopwatch.start. And then after this is done, stopwatch.stop. And then we'll print out the time elapsed in milliseconds. And then let's make this a string interpolation, so we'll put $sign in front. And we'll say stopwatch dot elapsed milliseconds. Okay, the total elapsed time in milliseconds. Okay, now again, this is not seconds, it's milliseconds. We need 1,000 milliseconds in order to equal 1 second. So we're going to run this 100,000 times. Now, yes, the first time it runs, it will be compiled. After that, it will use that cached version. Let's run this. It's done. We've run this in 50 milliseconds. 100,000 times, 50 milliseconds. Now, let's run it again. Just want to show you something. 50. Let's run it again. 51. Let's run it again. 51. Your computer might be different because you might have a different CPU, whatever, but it's pretty consistent around that, but it's so minuscule as far as time goes that a little bit of variation is fine. Now, let's change this to a not compiled statement. So we're going to say regex test equals new regex with a pattern. All right, this is an instantiated version of a regular expression. Now, when you use an instantiated version, you can pre-compile it. But if you don't, it will never be compiled or cached. I'm sorry, it'll never be cached for the next time. It'll always be compiled every time. So let's take this out. This is about 50 milliseconds, right? We're going to say test.isMatch for I am Tim Corey. It's the same thing. It's just using the instance which passes in the pattern ahead of time. But again, this is the not compiled version yet. So and we're putting this inside the start. So even if we compile, let's compile first. Options dot compiled. So this will compile it once and then reuse it over and over again. But again, we're testing it inside of the stopwatch.start. 49. Okay, 49 milliseconds. Let's run it again. 50. 47, 49. About the same. I mean, the variance is so little, it's not really a variance because of the fact that anything can affect this. Now, let's not compile it, which means it's going to compile itself every single time. 41, 42, 43, 41. It's actually a little faster. So when people start to freak out and say, oh my goodness, this is a thing you should never do, it's so dangerous, it's so expensive. Listen, regular expressions can be expensive. Don't hear me say they're not. However, when we say expensive, we don't mean never use them. What it means is be smart about it. If you have a loop with 1 million records you're looping through, and then you're running 3 or 4 different regular expressions on them, yes, that's going to be slow. But it might be necessary. The other part is, can you do this without a regular expression? So in these, I could have said contains. So does this contain Tim? I could have done that. Now, this, not so much. This is harder to do. I could have said starts with Tim or ends with Tim or contains Tim. I could do that, but that becomes like 3 different statements to run, which is where a regular expression starts to shine. So just saying, look for Tim, we could do this another way. But if you're saying, hey, I want you to find this pattern of things, that's probably going to be a regular expression. And it's okay to run it. Just look for any time you're going to be running it millions of times. Then you need to benchmark and figure out if there's a different way. But if you're running this 10, 100, 500 times even, you're not going to see a performance hit at all. But again, you should test in your scenario. You should know what where the performance bottlenecks are in your application. But performance bottlenecks are something you should find probably near the end of your project rather than trying to pre-do all of your efficiencies. If you say, you know what, we're not going to use regular expressions because they're slow, that's a bad take. This is a tool that is available and is the best tool for the job in a lot of circumstances. So be careful with some of the rhetoric around regular expressions because, quite frankly, it's not helpful to what we're doing, and it actually hurts you as a developer to not have this tool in your toolbox. So I just want to point that out, that they're not nearly as inefficient as you thought they were, especially not in newer versions of .NET. Now, if you go to .NET Framework, they might be slower, but in .NET 6, what I'm doing right here, super efficient. And again, always test. You can use a stopwatch. Just try it out. There's other ways of testing performance, but this is a quick way in a little console application to test just that one line to see how efficient it is. Okay, let's keep going. And what we're going to do is we're going to take on a more complex scenario. Now, let's do this. Let's move this up to the very top because I want to get close to this. We're going to use this quite a bit. What we're going to do is let's bring my Solution Explorer here, and I'm going to copy a text file. Let's see if I can just paste it in here. I cannot. Well, no problem. I'm going to open folder in File Explorer, and I'm going to paste into it a text file. And it's right here, test.txt. Now, let's go to the properties of this and say, yes, copy to let's copy of newer. Copy of newer to the output directory. And what is this? It's a text file. And if we look, it's a big text file. It's just almost, not quite, it's almost 1,000 lines. I'm sorry, 5,000 lines of text. And it scrolls off to the right. I think it's about 80 characters wide or something like that. This is lorem ipsum text. So I didn't use an online tool. I just went to VS Code and created an HTML document and said lorem And I think it was, oh goodness, I think it was 50,000 I asked for. So 50,000 words in lorem ipsum text, and I formatted it and saved it. But then if we look in here, I'm sure you'll see it just by scrolling through, right? In here somewhere are 6 phone numbers. Now, I'm going to give you a way to find them without a regular expression, just so you can know where they are. Do Control F and look for 555. That's in every phone number in here. So the first one is this one. On line 530, there's 440-555-5201. This is I used US format for phone number. We're just going to stick with the US format, okay? But there's one with dashes in between. Let's go to the next one. Well, this one at the beginning of the string, and it uses dots instead of dashes. This one, it's a phone number, but there's no separators at all. This one has the parentheses around the area code, a space, and then a dash here. And then this one kind of has mixed. It has a dot and a dash. And we have dots down here. I think that's all of them. Yep, back to the beginning. So that's our options for our phone numbers. Those phone numbers are hard to spot, and they're kind of buried in here. And the only way we really find them in this mess is if we, one, looked for 555, which I included in there on purpose, or we look for any kind of digits. But what if there's other kinds of things in here that have digits? Well, that's when we create a mess, because there's a phone number in here possibly, but is it a phone number, or is it an ID, or is it a zip code, or is it? And so what we want to do is take this text file and use this to really show off how powerful the regular expressions can be. So what we're going to do is we're going to look for those phone numbers in that text file. Let's start by looking up the file. So we're going to say string to search equals file.readAllText from test.txt. Now, a couple things to point out here. First of all, I'm reusing this variable. This is declared down here. So you cannot just uncomment everything and have everything run. You need to comment this out if you want to uncomment this. So I want to name it the same because I want to be as clear as possible. But then also, we're reading all text. Now, there's different ways to read a text file in. You can read all text, you can read all lines, and so on. We're going to read all text, which means that all 5,000 lines, or almost 5,000 lines, of lorem ipsum text is going to be put into this variable as a string. The whole thing. Now, if you had a million rows, that might not be efficient. You might have to stream the text file and then run it the real expression multiple times, which you could do. But in our case, this works just fine and it's efficient. So we're going to grab this, but I want to make sure that we have everything. So let's do this. Let's just say, well, let's create our pattern. String pattern equals, but then just put a breakpoint here. Okay, and we're going to run this just to make sure that toSearch fills up. That's all we're going to do. Breakpoint is hit, and toSearch, if you notice, has a lot of stuff in it. Okay, so if we mouse over it and look, it's got a lot. Now, that means that we, in fact, did read from our text file, which the text file is located without a path. What does that mean? It's finding it in the same location as our executable. That just means that when you go and download the source code, again, you can get the source code by using a link in the description. But if you get the source code, then it'll work for you too. Because I have it on my machine in a different location than yours, but because I put it into the project and said copy if newer, it's going to put it in the same folder as the compiled executable for our application. So now we have the entire file in this variable. Now we have a pattern to create. So that's next. And then what we're going to do is we're going to try to get all the matches. We're going to wait on the pattern for a minute. And we're going to say match collection. We're going to call it matches equals, and it's actually already telling me what I should probably do, which is regex.matches. Again, this is the static version. And we're saying to search. That's the place to search. So that's where we're looking for the matches. And the pattern to find is this string right here. And so this matches, notice it's not the same as we did down here, which is match. Is match just said, yes, I found a match. But matches says, hey, find me all, not just one, but all of the times that this regular expression matches and what the match was. Because again, we're not going to look for a specific phone number and say, is it in that file? Instead, we're going to look for a phone number pattern and say, what phone numbers do you find? There's the difference. So with our matches, we have what to search and the pattern. It's going to return a match collection, which is a set of matches. And then we can say for each match in matches, and we'll say console write line, and we can just say match, which is we can say match.value, like so. And that's just the actual printed out, hey, we found this match. So with our text file, we could find something like, let's just look for Dolores, right? If we do this pattern match and we run this, we'll see it found Dolores a lot. That's because it uses that word over and over again when we're doing our lorem ipsum text. But we're not looking for Dolores. We're looking for a phone number. Well, let's define a phone number. What is it that makes up a phone number? Well, it's going to have digits. Now notice here we have /d, lowercase, which is a digit character. So we're going to want to find a digit character. Now, if we just said, oops, we need to say that this is a string literal. So if we said we just want to find a digit character, it's going to find a lot of them. In fact, if we run this, there's all the digits found. But that's not really a phone number. That's just finding every place we find a number. We want a pattern of numbers. So we want 3 digits together is the first section. And we have the ability to use the curly braces to find a repetition. Now, this pattern right here says repeat low to high. So 1 to 3 of whatever precedes it. So if I were to say, 1, 3, this would say 1 to 3 digits. But we don't want that. We want 3 digits. Now, if we don't have the n, the y, that says at least 1. But if we drop the comma y, see the difference there? If we drop the comma y, that means that many. So I'm going to say 3 digits. I'm looking for specifically 3-digit patterns. Now, if we run this, we'll see we have a number of 3-digit patterns. But that's not good enough because that's not a complete phone number. That's just the first part. But then you want to say, okay, I want to have another 3-digit pattern. Okay. Another 3-digit pattern, and then a 4-digit pattern. So what this would find, let's just put a search here. This would find the 440-555-1212 or whatever the actual phone number is. That's what this would find. Now, you could have just said digits of 10 and find this, but let's run this. And sure enough, it found just one. 440-555-4567. That's the one phone number that matched this pattern exactly. But we have options for phone numbers. For example, sometimes people, I have 1, 2, 3, 4 there. Sometimes people put the dashes in between. Well, let's handle that. So in between our first 3 and our next 3, we need to have a dash. So we're just going to say dash. And we'll do dash between the next 3. And this is a regular character, so it works just fine just as a regular character. If we run this, we found the one that has dashes, but we didn't find the one we just found because we don't always have dashes. And that's where this character right here comes in, the optional preceding character match, which means that if we put a question mark after our dash, we're saying it can have a dash, but it doesn't have to have a dash. Okay, so let's run this again. And now we see 2 matching numbers. We found the one that has no dashes, as well as the one that does have dashes. Now, let's look at what else we could do. Well, sometimes people will put the dot in place. Okay, so let's take care of the dot as well. We already have a dash in that place. How do we do a dot? Well, we can do the or. So it's either a dash or a dot. So if either of those is true, let's do this for over here as well. If it's either a dash or a dot, and it's optional, this optional now applies to everything inside the parentheses. So it can have nothing, it can have dashes, it can have dots. Let's run this again. And now we have 5 phone numbers. We have the dashes, we have the dots, we have nothing, we have the one that has mixed dots and dashes, and we have the other one that has dots. So we've now found 5 different possibilities. We haven't found the 6th. So where do you find the 6th possibility? Well, we can look for the one that has this. And this is another way that, and yes, we have a lot of different ways to create phone numbers, right? This pattern, where you have an open paren and a closed paren, and then you have a space, or not, but usually a space, and then you have a dash. Well, in order to do that, we need to start off by looking for an optional parentheses. So we could say parentheses and a question mark, meaning optional, right? Well, not quite, because remember, we use parentheses to use this for an alternate. So how do we put an actual parentheses in here? We have to escape it. So now you've escaped that to say, no, this is just a parentheses. Okay, so we're looking for this as a optional parentheses. And then we'll have to look for an optional parentheses at the end. All right, so we're going to say slash parentheses to escape that parentheses, but that's optional. And then we could have a dash or a dot. We also have a space. So let's have another option in here, slash S for space. Whoops, wrong slash. Slash S for space. Again, that's up here, white space. So now we have a optional opening parentheses. We have our 3 digits. We have an optional closing parentheses. And we have an optional space, dot, or dash. Now, why didn't I just put this inside of my set of ors? Well, because it's actually 2 characters that may or may not be there. So this is optional, but if we have this parentheses, we probably have a space as well. So that's where that or comes in. We don't have to. So that's why I've separated it out. And yes, now we're starting to look like a very complicated statement. We've got all these slashes and squiggly brackets and question marks and dashes and dots and all the rest. We're saying, man, that looks complicated. But when he broke it down and figured out what it does, it works great. We've now found the 6 phone numbers that I buried in that text file almost instantaneously. This thing is super fast. So that's why regular expressions are so powerful. If you decide you want to look up and find a phone number in this whole huge text file, you think, I think they left me a phone number somewhere. There you go. Quick lookup. If you want to pull out certain patterns like an email address or Email addresses are hard, by the way. Don't think that you've got it conquered. There's some complexity around an email address, but phone numbers, zip codes, addresses, names, words, so many different things you can find using regular expressions. And while the statements do start to become rather complicated, at least looking, when you start to break down exactly what they're doing and reading them character by character or two characters at a time sometimes, like, for example, okay, this is an escape character. What's it escaping? A parenthesis. So it's just a character, the parentheses character. This means the preceding is optional. So that is optional. Okay, this means a digit. This means times 3. So I'm looking for 3 digits with a possible parenthesis in front of it, and then a possible parenthesis afterwards. You start to read through this and you go, wait, that's not that complicated. It's just, it looks ugly. It's not easily human readable. You don't just look at this at a glance, at least I don't, and go, oh yeah, I was looking for phone numbers. That's hard to do. But when you start to slowly build it up over time, you create this complicated statement that does exactly what you're looking for. Now, we could make this even more complicated, and we probably, if I was going to create this for a customer, I probably would make it more complicated. And the reason why, and this is where you start to think through and use the logic you've been building as a C# developer, think through the edge cases. Now, it's found all the ones I put in there. However, it only has phone numbers in that file that are actual numeric. The rest aren't phone numbers. So I would throw in there a few other things that aren't phone numbers, maybe maybe an ID code. For example, if we had, 112-3456789 0. That's technically 10 numbers. Make sure that doesn't trigger a phone number. That's an ID number. That's not a phone number. And then you have to think through, what if they put the 1+? If you're in the US, that's the country code. So you had, or +1 like that. That we're not picking up the country code. So if it's a different country code, that'd be a problem. It doesn't work with international phone numbers. Do we think about that? Do we think through things like, well, what if there is a, I don't know, if I were to say 1, 2, 3, and then we're to say something else, maybe a zip code, and I say like that, is that can get triggered somehow by a phone number lookup, and start throwing these edge cases at it to see if you can figure out, well, what if there's a, is that a phone number? No, it's not a phone number because it's not the right number of characters, but it would be picked up as a phone number because it found this. And so this is a phone number. So you need to think through, okay, kind of like with our name here above, or down below actually now, does it have to have a space around it? Does it have a space on both sides? If it does, then you have to look for the spaces around it as well, and then think through, but what if it's at the beginning of the file or the end of the file? And you can start to get more detailed that way as well. And your regular expression will become more and more complicated as you do. But you'll be dialing in more and more specifically what you're looking for and what you're not. Okay? So these are super useful in certain circumstances. Now that you know how to use a regular expression, don't look at every lookup problem or query problem as an option to use regular expressions. Okay? Make sure that the solution fits the problem. This is a tool. It is not meant to replace every other tool you have. Use it when it's wise to do so, when this is the best option. If there's another option that is simpler, use the simpler option. Because when you're scanning through your code, that's kind of a road or a speed bump. Okay? Remember, I've said a number of times that source code is meant to be read by humans, not computers, humans. That's what it's meant to be read by. Now, computers do read it and they do compile it. But remember, computers compile things down into ones and zeros. We don't read ones and zeros. We read C# code. And that's why it's meant to be read by humans, because we're going to be the ones debugging it. We're the ones that try to understand it and to improve it. And so when you read down through source code, it's very easy to read write console.writeline. Okay, that's writing to the console. Cool. Stopwatch. Okay, I understand what a stopwatch is. Stopwatch.start. I got that. Stopwatch.stop. I got that. Even if you didn't know about the stopwatch class before this video, you probably have a pretty good grasp on what it's doing. It's starting and stopping a stopwatch. That's human readable code. When you get to a regular expression and you see pattern, and you see that, you go, I have no clue. And so you have to stop your reading, your perusing, and say, okay, what is this doing? And you start one character at a time. And if you're like me, maybe you're not. Maybe you look at regular expressions and go, man, I got it. That's super simple. That's a phone number. No problem. I see the 334 pattern and the question mark. Got it. But for me, I have to go through and read character by character and write things out and kind of figure things out. It takes me a long time sometimes to figure out what a regular expression is doing or trying to do. One thing that would help, and I highly encourage this, some people say that you should never have code comments. That's wrong. That's just wrong. Whenever you say never in programming, you've probably made a mistake. Because if you go to an extreme, always or never, then you are leaving out any possibility for an edge case. And life is full of edge cases. If you speak English, you know there are tons of edge cases in our language itself. So edge cases are a thing because the world is unique. It's not like we fit into the same pattern all the time. Otherwise, we wouldn't need software developers. We would have solved every single problem because it would have all been known. But no, we have edge cases. So when it comes to code comments, I don't recommend commenting things like the stopwatch.start. That's pretty obvious what it's doing. That's code that you can easily understand. But this, I would say, this pattern matches phone numbers. And I might even say in the following patterns and specify them. Okay. The only thing is, and this is where the no code comments people have a good point, is that if you come back and say, oh, we need to adjust this to also take into account the idea of people using, commas instead of periods as well. Okay. Well, you need to update your code comment as well. Because otherwise your code comment is out of date, and it's actually worse than not having a code comment sometimes, because the code comment is what's easily readable, and some people read that and believe it. And if it doesn't match what's actually happening, that's a problem. So if you do have a comment, you have to maintain it. Otherwise, it's actually worse than not having one. But in cases like this, it's important to have a comment to make it easier for people that are scanning your code that don't necessarily need to handle updating the pattern, because maybe they're just looking for another part in this section. They don't need to understand everything that is doing. They just need to know, oh, that matches phone numbers. And that's really all they need to know. And so that code comment is very, very helpful for that. So that is the intro to regular expressions. I could go on for a full course on just regular expressions. There's lots to get into with them. There's lots of ways to make them more efficient and to choose different options for the same pattern. And there's lots of cool patterns you can create. But I think this gets you started. And again, up here we have all of, well, not all, but a lot of the most common things you can do with a regular expression. And hopefully that will help you get started looking for things. I would encourage you, practice what you've learned today. Don't just watch this video and go, okay, I got it. Let's move on. I'll use it in production when I need it. Practice it. Create a console application, nothing complicated. Just a console application, and do some testing. And then, you know what? If you have questions later on, throw in your stopwatch and say, hey, is this efficient? Is it not efficient? Is there a different way of doing this? Can I compare to? If you really want to get into, you can use the benchmark.net, which I've got a video on, where you get more in depth into benchmarking the different options. But really, like I've shown you, it is super efficient in most cases to use a regular expression, as long as you're not using it millions of times. So with that gets you started. Let me know down in the comments what your thoughts are on regular expressions, how often you use them, and if you feel more confident now in using them. Thanks for watching, and as always, I am Tim Corey.